Jupiter doesn't just have moons. It has a system. Orbiting the single planet are dozens of worlds, some larger than planets, some no bigger than mountains. Together, they form a miniature solar system locked around one massive body. This isn't normal. Most planets have only a few moons. Some have none. But Jupiter gathered them by the dozens. Its gravity is so powerful that it didn't just capture one companion, it captured an entire family. Some of these moons are ancient, formed alongside Jupiter itself. Others are outsiders pulled in and trapped over billions of years. Each orbit tells a story of chaos, collision, and control. To understand why Jupiter has so many moons, you have to understand what Jupiter really is. Not just a planet, but a gravitational empire. And once you see that, those moons stop looking like an accident and start looking inevitable. Jupiter's greatest power is not its size or its storms, it is gravity. Jupiter contains more mass than all the other planets combined. That enormous mass creates a gravitational field so strong that space around it is deeply distorted. Anything that passes too close doesn't simply fly by. It feels Jupiter's pull. In the early solar system, space was crowded and chaotic. Asteroids, icy bodies, and fragments of rock moved on unstable paths. When these objects entered Jupiter's gravitational influence, many were slowed, redirected, or captured. For an object to become a moon, it must lose enough energy to remain bound. Jupiter's gravity made this possible in several ways. Some objects collided with existing material, losing speed. Others were captured during close encounters involving multiple bodies, where energy was exchanged and one object became trapped. Once captured, Jupiter's gravity keeps these moons in stable orbits. Inner moons move quickly, held tightly by the planet's pull. Outer moons orbit more slowly, forming distant, irregular paths. Together, they create layers of motion, each one defined by gravity alone. Jupiter's influence is so strong that it dominates the space around it, a region known as its gravitational sphere of influence. Within this zone, Jupiter controls the motion of moons, dust, and debris more strongly than the Sun does. This is why Jupiter continues to collect moons even today. Passing objects can still be captured, especially at the edges of its gravitational reach. Jupiter doesn't need to search for moons. Its gravity does the work. Anything that wanders too close, slows down just enough, and enters the right path can become part of Jupiter's growing system, held in orbit by one of the most powerful gravitational forces in the solar system. To understand why Jupiter has so many moons, you have to go back to its formation. Jupiter did not form quietly. In the early solar system, the region around Jupiter was filled with gas, dust, and ice. As Jupiter grew, it became massive very quickly. Its gravity began pulling in material not just to build the planet itself, but to form a disk of debris around it, much like the disk that once surrounded the young Sunday. This disk became Jupiter's own miniature solar system. Within it, material collided, clumped together, and slowly formed moons. These moons didn't arrive later, they were born alongside Jupiter. The largest of them, like Io, Europa, Ganymede, and Callisto, formed in orderly orbits, similar to how planets formed around the Sunday. Each moon settled into a specific region based on temperature and available material. Closer moons formed from rock, farther ones formed with more ice. This layered structure mirrors the larger solar system, where rocky planets lie closer to the Sun and icy bodies dominate the outer regions. Jupiter's gravity controlled this entire process. It regulated how material moved, where moons could form, and how stable their orbits would be. The Sun's influence was still present, but within Jupiter's domain, Jupiter ruled. Even today, the structure remains visible. The regular orbits of Jupiter's largest moons reflect their shared origin. They are not random captures. They are products of an organized system that formed around a growing giant planet. Jupiter didn't just gather moons by chance. It built them. In doing so, it became not just a planet, but a scaled-down version of a solar system, complete with its own worlds, rules, and long-term stability. Jupiter's moon system did not freeze in place after formation. It kept evolving. Long after the largest moons formed, Jupiter remained surrounded by a chaotic environment. Asteroids, comets, and icy fragments continued to pass through its gravitational domain. Over billions of years, many of these objects were pulled in, broken apart, or trapped. Some moons are the result of capture. These objects were not born near Jupiter. They arrived later, wandering through space until Jupiter's gravity altered their paths. If conditions were right, they lost enough energy to remain bound, settling into distant, irregular orbits. Other moons formed through collision. Larger captured bodies were torn apart by tidal forces or shattered through impacts. The fragments spread out and became small moons, each following its own path. This is why many of Jupiter's outer moons are tiny, unevenly shaped, and grouped into families that share similar orbits. These moons tell a story of violence rather than calm formation. Their tilted, elongated orbits reveal that they were not part of Jupiter's original system. They are survivors of encounters, leftovers from collisions that reshaped the space around the planet. Even today, this process has not completely stopped. Jupiter continues to influence passing objects, altering trajectories, and occasionally capturing new ones. The number of moons can still change. This is why Jupiter's moon count keeps growing. It is not static. Jupiter began with a structured system of large moons. Over time, chaos added to it. The result is what we see now, a planet surrounded by dozens of worlds formed through both order and disorder. Jupiter's many moons are not a coincidence. They are the record of billions of years of gravity at work.